As sort of a math refresher, let's start out with recalling how to do arithmetic on sort of coordinate systems. So I've got two quantities to my left, x and y, and we're going to consider these objects to be vectors in a two-dimensional space. So x is going to be up here at 3, 4. So if we were to say that this was 3 and that this was 4, because we've represented x sort of with the angle brackets, that means it's a vector in this space and not simply just a point in this space. Vectors, again, have a length to them. So that's x. Y is going to be in a different spot. It's going to be at -1, and then it's going to be a little bit lower at 2. So we'll sort of exaggerate here a bit and say that y, the y vector, is at that spot. Now, when we have vectors in a coordinate system, operations like addition are really straightforward, and we do them component-wise. So if I'm adding vector x and y together, then I will just take the individual components of each and add them together. So this is the first component. I'm going to add those two together and make the result to be 2. And then I'm going to take the second component, add them together, and the result is going to be 6. So if we were going to plot this graphically and say that this result here was called z, for x plus y is equal to z, then z would be at the point 2, 6, so sort of somewhere up here. And just in the same way that we can add vectors, we can also subtract them. So if we were to subtract x and y and make some value q, then it would be 3, 4 minus -1, 2. And again, we've got a minus. We are subtracting a minus, so let's take care to remember where our signs go. This would end up being 4, 2 would be the result there. 3 minus -1 is 4. 4 minus 2 is 2. And so our vector q would be somewhere out about here. So that would be our q vector right there. So the basic arithmetic operations of addition and subtraction are really easy with a Euclidean coordinate system. But what we're going to see in a second is that we want to be careful when we start to talk about multiplication. Like, what do we exactly mean by this operator? And we'll do that on the next slide. So we saw how easy it was to add and subtract vectors in a coordinate space. Let's talk now about how multiplication may work. And so you may see a lot of terms that have sort of x vector multiplied by y vector. Now, I use the word multiplication loosely, and probably my mathematician friends hate me now, but we need to be really careful when we use this operator. Do we actually mean multiplication? So do we actually mean to multiply these things? Does it mean the dot product as well? Because that's another operation we can do on vectors. Or even to be more complicated, if we write the operation like this, is this then even the cross product of these two vectors? And so often we will write things that look like this, or we'll have some sort of expression that says, x is equal to y times z, but we want to be very clear about the operation that we are describing. So for the sake of our course, what we will do is, if I actually want to multiply the x vector and y vector, I'm going to write them out in a rectilinear form. So this vector 3, 4, because we are in the coordinate space that is complex, meaning we are in the complex plane, meaning that the x component is real and the y component is imaginary, I can write out x as 3 plus j, 4. So that's going to be our x quantity, and then I will multiply it by our y quantity, which will be -1 plus j2. So what I've done is just translated that component down to here, and then this component down to here, and I've moved them from a vector format to a rectilinear format. Now we can use our algebra properties as we've before, and we will just distribute all of these terms and get -3 plus 6j plus negative 4j plus 8j squared. And we need to remember, though, that j is equal to the imaginary term, and if we recall that I squared is equal to negative 1, we can start to combine all of these components. And so this j squared over here is actually going to become a negative 1. And then we've got our 4j, our 6j, and our negative 3. So all of these items combined turns out to be negative 11 plus 2j. So negative 3 and negative 8 make negative 11, and 6j and negative 4j make 2j. So for our particular course, when we go to multiply components, we are going to do it in this rectilinear format, and this is the result that we expect to get.